Good afternoon, everybody. I hope you can hear me and also, in the meantime, see my screen.
Yes.
Then I just can see. Is this now the full screen that you see? Because I can't see it here on my.
Yeah, we see it.
Okay, there we are. Yeah. So I want to switch between two apps, between the presentation and on the one side also the web browser, to show a little bit that our product passport is not only working on paper but also working online already. And before I start, let me first give you a short introduction to who we are. So ECRA, the European Carpet and Rug Association, is located in Brussels. GUT is located in Aachen, Germany, where I sit today. And we are an organization of about 44 carpet producers in Europe, mainly active in the field of wall-to-wall floor coverings, but we also, or our members also cover most of the other applications where carpets are used. I'll come to this later on. And with respect to our circular economy strategy, we have identified more or less 3 sectors in which we have to be active. Number one, we have to switch to a smart selection of materials, which finally means that different from the past, where longevity of the product was in the focus, we now also have to look at materials that allow the recycling of the materials. Then we have to talk about transparent information exchange, because that is necessary not only for the chemicals used, but also for the materials and the types of product we are using, so that at the end, the recycler knows what to do with the product. And to make all this happen, education and information along the chain is one of the most important and crucial things that we have to look at. So if we go to the next slide, then we see roughly the fields of application in which carpets are used, because most of the day when I have discussions with people about carpets, this is a complete mix of everything. But if you look here at this slide, you see that on the one side, we are talking about textile floor coverings and rugs and runners, which are used in the indoor environment. Only one part of these indoor carpets or carpets that are used in indoor environments are construction products. These are the wall-to-wall floor coverings, whereas rugs, runners, and mats are mostly unregulated products. They are just home decorative articles. And then, of course, we see that carpets are used in the automotive industry, but also in cruise ships and in planes. And also, if we look at the big field of sports application, we do have quite an important amount of carpets that are used outdoors. So from that point of view, we need also to look a little bit at the volumes that we are talking about. And that is not quite easy to evaluate, because there are, on the one side, the imported materials from the rest of the world that we have to look at. On the other side, the EU is also exporting carpets to the rest of the world. And then we have within the EU a real nice volume of intra-EU trade. So that based on these figures, we can roughly say that 685 million square meters of carpets used in all different applications remain within the EU market. Now, if we look at the next slide, we see the typical materials that are used in carpet production. Number one, we have a limited amount of polymers that are used. It's mainly polypropylene, polyamides, and some polyester types. Then we have for the backing layers, lattices, polymer dispersions, sometimes also thermoplastic elastomers that are used, some bitumen, whereas PVC and polyurethane are currently not amongst the volume materials that are used. It's only in a very limited amount of carpet sectors where PVC is still used. Then we have natural materials, mainly it's wool, jute, and sisal. And then we have the other materials, mainly chalk and aluminium trihydroxide, which is used as a flame retardant, pigments, dyes, and additives. Now, the next slide gives us an impression on the volumes of the different materials. So we see that PP and polyamides carpets are the majority of products that are used, whereas wool carpets, carpets with natural fibers, and other polymers are in the minority. So a strategy that focuses on recycling and circular economy, therefore, of course, should start with these major volumes that we have, and the strategies should be designed to get grip on these amounts of materials. Now, of what materials are we talking, or what volumes are we talking? First of all, if we look at a typical wall-to-wall carpet and the typical volumes that we have in Europe, then we are talking about 224 kilotons of polymer fibers. So compared to the overall millions of tons of polymers that are used in Europe, this is quite a small volume or a small mass that we have. But on the other side, we also see that 55% of such a carpet today is simply inorganic material, which is used as a filler. But we come to this later on also, because that is one of the important points in the strategy. We heard already that the information on the material composition is important. So first of all, we need to know whether this product could be used for an extended use phase, whether a product can be separated into components, and these components later on could be separated into monomers or polymers, or whether fibers can be directly used. It's also necessary to see whether the product at the end of life that is treated is compostable, which means it is really a bio-based product that can again be decomposed into CO2, NO2, and water, so the base molecules, or whether this product, due to material composition, is better incinerated. And this is something that we need to think about, that products that are becoming waste today have been produced 10, 15, sometimes 20 years ago, and the information on these types of products is limited. So it might be the right solution to use these products also for the next coming 5 to maybe 8 years as secondary fuels. On the other side, there might be products that are better decomposed into base chemicals, based on the fact that the polymer mixtures or the material mixtures that you find in these products are simply too complicated to separate. But by doing this process, you still can keep the carbon in molecules and use them as base chemicals, again for the production of monomers and then polymers, so that you can close the cycle via this route. And when we think about EPR schemes, and recycling of products, we should not only look at the European market, which is a complete mix of all different market situation. And I looked here just at the two biggest markets for carpets that we have in Europe. Still have in Europe? No, not still have in Europe, because the UK has already left, but it is, besides Germany, the biggest markets for textile floor coverings. And what we see here is that the composition of the products differ dramatically. Whereas in the UK, we see that 80% of the tufted carpets that are sold there are broadloom PP carpets. We see that in Germany, we have here a mix of broadloom PP, 35%, and 55% polyamide. And that means that any strategy that we are developing, or that is going to be developed in future, needs information on the material composition, so that the final recycling options per market can be identified, and everything is done in the most successful way. Now, when we look at the information flow, what should be in the focus? Yes, substances of concern should be in the focus and have to be in the focus, because they can significantly disturb the material cycles. We heard already this during the presentation from Martin, but the question is whether this alone is sufficient, and I think no, because at least for the flooring sector, but also for many other building products with a relative long life cycle, also other types of information flow is necessary. So what else should be considered? Number one, it's the material composition, because at the end, when it comes to the recycling, the recycler needs to have a business case. So if he does not get the information how much of polypropylene or how much polyamide he can find in a specific product, then of course his willingness to do whatever recycling operation on this material will be very low. And therefore, the amount of the materials needs to be communicated. And on top of that, also the accessibility of the materials, because there might be some products where you can very easily separate the materials, and others, depending on the production process, might be more difficult to separate. And then, of course, we have substances that can disturb recycling, but these substances not necessarily have to be SOCs. So also this information is needed. And this is, of course, the today quite huge amount of inorganic materials that you find in carpets. And if the overall volume is 55%, then that means that at the end, you, or at least at the starting point of the recycling operation, you have to handle 55% of material that later on does not have the biggest value when you try to use or to reuse these materials again. And then, of course, we should also think about useful information for the use phase of the product, because one of the lessons we learned already some in the meantime 15 years ago, when we had a project that was called co-care, coding for carpet recycling, was simply the fact that at that time nobody could identify the benefit of printing a code on the carpet that and with the only purpose to be identified 10 or 15 years later. So that is then simply a cost question, and also a question of the durability of such informations that you print on the carpet or on any other product. So that means when we now look at the overall life cycle and information exchange, this should not only be done for end-of-life scenarios. So our approach today is that with the production of the carpet, we provide information into a data or into a database, which we call PRODIS, Product Information System. And the data that we store is, number one, the data on how much fiber material is used, how much different fiber materials are used, what type of backing is used. And via the GUT system, which looks at emissions and content of hazardous substances in products, we also store the core information on materials and chemicals that are used in this product. Now, with our new design product passport, we now have the possibility to provide information at any stage of the life cycle of such a product or during the use phase of such a product. Number one, when the carpet is delivered to the consumer, you can, via this system, get information on the right installation of the product, the right cleaning and maintenance of the product. Via the GUT system, the information on health and safety issues. If you are, or if this carpet is going to be installed in green building schemes, also the suitability for green building schemes. And on top of that, we provide information on the CE label. And later on, when it comes to recycling, either at a very late stage in the life cycle or at a very early stage in the life cycle, we have this information on material composition and the amount of different materials. But based on the information of production method, material combination, and technologies used at the production stage, we will also be able to talk about possible recycling options of the product. And this based on the recent technologies, that means either at that point or at that point. So if today the separation of, let's say, polypropylene fibers from the SBR backing is complicated, it might be that in 5 years' time, there is a technology available that would allow the easy separation of these materials, so that also this carpet, after 5 years or in 5 years from now, could be recycled, whereas today it would just be possible to use this carpet as a type of secondary fuel. Now, basically, we have in our, sorry, that was one too far. Basically, we have in our product passport the following information: material composition separated between use layer and backing, the information on chemicals used, for example, flame retardant or other hazardous chemicals. We talk about the recycled content, which is third-party validated. I'll come to this in a few slides from now. The recycling potential is something that is for the future. We just started working on that, whereas with the recycled content, we are already far and done important steps since the first meeting that we had on this topic just about 14 months ago, I think. Then we have safety information based on CE label and DOP. We give information on indoor air quality and additional EPD information for the product, and all this is finally online available. So how does this look like? So we have a web page. We switch in a few minutes to this web page so that the following slides can be seen online live on the web page. What we use in our product is a QR code and a license number. So either you have access to this information direct via the QR code or manual via entering this license number, which is product specific, into the system. Now, one of the things that we need to talk about for sure is the secure and permanent information transfer. Today, when we use labels or when we use QR codes or when we use documentation systems, this is not perfectly guaranteed, because these products or these information tools are not safely attached to the product. So one of the possibilities that we are looking into is, for example, the use of micro RFID chips. Martin Für mentioned this already earlier. This is such an RFID chip which is incorporated in yarns, and of course could be used for a permanent transfer of the ID, and the ID would then be the uniform ID of the specific product in our produce database. Now, how does all this look like? The core information on the product. I switch now to the web browser so that we can have a look at the product passport and how it works. So I need now to use the license number. And then click OK. And what now happens is that the information is directly taken from our database, and you already see that the core information is the product name, in this case L480. You see the corresponding CE label, also with the information on the producer. You see pictograms explaining the essential characteristics of the products, and here the pictograms which are used for the definition of the use scenario. So that means it gives information on the quality and the use aspects of the carpet. We have then on this web page a full information on the product, how it is produced, about the use layer, the composition of the surface. In this case, you already see that this is 100% polyamide 6 product with a recycled content or a recycled proportion of 100%. You see here the information on the backing, as well as on thickness, total mass, and weight of use surface. All this information later on can be used to give the recycler the information how much polyamide he can find per square meter or per kilogram of that carpet. Now, the use properties are important for the consumer to make an educated choice on this product, so that he uses this product in the right use environment. That of course means that if you want to install such a carpet, let's say in an office building, it should better have a use class 33, and you should not choose a carpet which can only be used in private homes, for example. Then we give information on emissions, chemicals, and pollutants. This is the short summary, and later on you can here get direct links to the section where we explain exactly what is meant by biocides, what is meant by active biocide treatments. We have a section for substances of very high concern, which yet is not full operational, but we are working on this issue, so that from spring 2021 on, this information will be available, and we have 3 classes of information. Number 1, within the framework of the GOT criteria, the active use of substances of very high concern is not permitted, but we also will give the information on the different level of possible candidate substances, each with the name of the substance and the CAS number, so that that can also be followed. Digital CE marking means that all these essential characteristics that are requested by the CE label will be explained and will be documented in this page. But what you also see is that the DOP document, which is the document that the producer has to provide, is available in 28 languages. We now can download one in English. That's not the document. One moment. There we are. This is the document that belongs to this product. It is, you see it here, it's Balzon is the producer, and the product name is L480. No, that was wrong. Where am I? There we are. And we have also linked this product with a set of EPD documents. You can here download the available documents in English language. This is the document that you can download, and one moment, and also a very specific EPD document for this product. So I now switch back to the presentation. One moment, I have to find it. There we are. Back to the presentation, where we now, this is the summary on the EPDs. And when we now look at the recycled content, there we have already started an active work item on standardization. This is done in CEN TC 134, work group 8. And the title of the standard is Definition and Declaration of Recycled, Bio-based and Renewable Material Content, Organic and Inorganic in Textile Floor Coverings. So we hope that also in spring 2021, this work is finalized, so that based on this standard, we can start to communicate the recycled content in a harmonized format. And at the same time, we have set up together with EUPC, VKC, and ESLA, BQA as one of the certification bodies, and Centex Bell, an organization, an umbrella organization, which is called Polycert Europe, which with the purpose of creating a harmonized scheme for the overall declaration of recycled content in materials. And this scheme is also divided into 3 sections. So if you go down to the section 3 of this certification scheme, then you will also there get the information on hazardous substances that are contained in the recycled material. All this to make sure that the communication along the chain and the trust between the partners in that recycling scheme, recycling chain is guaranteed. Now, the big question always is where to start, and that is then the typical chicken and egg problem. So you can, of course, start with a sustainable product design. You could also start with collecting and sorting, and you could start with developing technical solutions for material processing. According to our viewpoint, you have to do basically everything together at the same time, so that at the end you will be able to bring all these aspects together at a very specific point in time. So what are we currently doing? We are closely looking into the collecting and sorting of flooring materials. When we start with all types of flooring materials, we are focusing here on floorings for domestic and commercial areas. We do not look at ceramic materials or floorings for industrial applications, as these are totally different fields. And finally, we also do not look at wooden floorings. That means 100% solid wood flooring materials. But what we look at are carpets, resilient floorings, and different types of laminate floorings. And staying with the carpets, we make also a clear distinction between wall-to-wall carpets and rugs and runners. The reason for this is that we, at the time, due to a lack of information regarding rugs and runners, which are mainly imported from the Far East and China, that we regard these materials as impurities when it comes to the recycling of wall-to-wall carpets. And within the group of wall-to-wall carpets, we are looking at broadloom and tiles separately, so that at the end of this process, we get a pre-selected amount of materials based on the polymers that are used in the use layer. And from there, we can start with the further separation into fibers, the purification, so that at the end we do have a PET fraction, a PP fraction, and a polyamide 6 fraction, which then can be used in different applications. But we also look for technical solutions for material processing. So that looks quite complicated, and this is taken from a proposal for a Horizon 2020 project that we are just working on. But what this shows is that also with the what we call ePro, this electronic product information system, with the tags, with the RFID chips, we could get a better identification of the product already with the information, whether it is a broadloom carpet, whether it is a carpet tile, or whether it is just a doormat. So that based on this quite coarse separation or identification, it is already better possible to use the right recycling routes and new technologies. For example, here, the Polysep, which is a separation technology of fibers from the backing. And that means that with the next step, the sustainable product design, where we have to reduce the amount of products that go to energy recovery, thus reducing the CO2 emissions during the incineration of these materials. We have to increase the amount of fiber material that goes into a pool of recycled materials. We call that polymer pools, from where we can take new materials and selected virgin raw materials, which in a smart production process finally will allow to reduce the CO2 footprints of the materials dramatically. One of the perfect examples is the polyamide 6 cycle, where polyamide 6 can be taken out of this PA6 polymer pool, which then either can go to chemical recycling to produce caprolactam, or to mechanical recycling just to produce new fiber materials. It can be used then for the production of a carpet. And finally, after the use phase, this cycle can be closed. What does this cycle mean for the overall CO2 reduction? You saw a little bit earlier that we currently calculate with about 49 kilotons of polyamide 6 yarn that is used in tufted carpets or in carpets today. And if we would use virgin material, this would amount for 450,000 tons of CO2 emissions. If we would use already 100% recycled polyamide 6, this would reduce the CO2 footprint of this material by down to 132,000 tons, and taking into account that the carpet itself will be recycled later on, and we calculate then with a 70% recycling quote, this would halve the amount of CO2 that is emitted today. So from that point of view, I think it is important that the information exchange is set up in such a way that not only the information on substances of concern is communicated, but also the different recycling options for a product, the material combination, and the possible use scenarios for such a product. Number one, to increase the lifetime of the product, and also to guarantee after this lifetime the safe and optimized recycling of the product. So that's the end of my short presentation. Thank you.